So today what we're going to do is we're going to take all that you learned on first and second derivative, and we're going to put it into one problem. So what I've done is I've printed up your My Math Lab, and I'm going to use one of the examples on My Math Lab. So this one is going to look familiar. For some of you, it's going to be the exact same one. For others, it's going to be where it just changes the numbers. So here is our function. And we're going to use both first and second derivative to graph. And what I'm going to do is I'm going to go through everything as if I'm doing it on My Math Lab. Okay, so there's our function. And it says, the very first question is, find the intervals on which the graph of f is concave up, the intervals on which the graph of f is concave down, and the inflection points. So this is an example of just doing second derivative. The minute you see concave up, concave down, that means you're looking for second derivative only. So that's all you have to go to is just go right to the second derivative. So remember, we have to go through the process of finding the first derivative. So this one is an example of just the second derivative. We'll use first and second in a minute. Okay, there's my first derivative. Since it's asking for concave up or concave down, I have to go to my second derivative. And again, what I'm doing is the power rule. Drop the 3 to the front and multiply by -4, I get -12, and then I subtract 1. Drop the 2 to the front and multiply by 36, I get 72, and then I subtract 1. So it's just the power rule. Okay, so I've found my second derivative. Now I need to find my possible points of inflection. So I do that by setting my second derivative to 0. And now I'm going to solve. So I can factor out a -12x out of both pieces. Anytime my first term is negative, I just factor it out. It just makes it easier. So I end up with x minus 6 equals 0. And again, if you aren't sure, just multiply these back through. -12x times x gives me -12x squared. -12x times -6 gives me a positive 72x. And now I just solve for x. So x is going to equal either 0 here, because -12 times 0 is 0, and x is going to equal 6, because 6 minus 6 also gives me 0. Okay, so those are my possible. So remember, we always want to say they're the possible ones. We don't know for sure yet. Not until we set up our test chart do we know if it is actually a point of inflection or not. So these are our possible points of inflection. The minute we get our points of inflection or possible points of inflection, now we're going to make a test chart. Okay, so I'm going to try and do this all on one board. So we have to make a test chart. Notice I labeled it as second derivative, so I know I'm using my second derivative function, which is this one, and then I can test my intervals. So at the second derivative, all the values below 0, so I'm going to pick -1. I plug it into my second derivative. I like to use it when it's already factored. It just makes it easier to find out if it's positive or negative. So -12 times -1 is a positive answer. -1 minus 6 is a negative answer. So in this interval, it's negative, and I have it concave down. Now I'm going to check the middle interval. And again, I'm using my second derivative. So between 0 and 6, I'm going to use 1. It's easiest. I plug in my 1 here. -12 times 1 is negative. 1 minus 6 is also negative. So in that interval, my answer is always going to be positive. So it's going to be concave up. Now I look at my third interval. Anything over 6, so I just pick an easy number to work with. -12 times 10 is a negative. 10 minus 6 is a positive. So my whole interval is negative. So what this tells me, I'm going from concave down to concave up. So this is a possible point of inflection, or this is a point of inflection. This one goes from up to down, so concave up to concave down. So this one also is a point of inflection. So it went from a possible point of inflection to an actual point of inflection because I have a change of concavity. All right, so then the first question. So I did all of this before I could answer the first question. So go ahead, every time you get a function, go ahead and walk through the process. If it asks for increase or decrease, where is it increase or decreasing? That's first derivative. If it asks for concavity, that's second derivative. So now I have my test chart. Now I can answer all the other questions. So the first question says, for what interval of x is the graph of f concave up? So concave up is here. So it is in the interval between 0 and 6. So again, you're going to write it in interval notation. We don't include 0 or 6 because those are the points of inflection. So it's not up or down at that point. That's where the concavity changes. So for for the first question, it says type your answer in interval notation and then use a comma if there's if you want to separate them. I know I talked about using a U, which means union. You don't need to do that. Just use a comma if there's two different intervals. So on this particular question, my interval is concave up between 0 and 6. So I'm going to answer between 0 and 6. So this is interval notation. Okay? So then the second question says, for what interval of x is the graph of f concave down? So this is, I'm going to do it this way. That's my concave up. Okay? So where is it concave down? Well, I look at my test chart. It's concave down here, and it's concave down here. So when you write your, I better not do it this way. So when you write your interval notation where you have two different intervals that are concave down, in MyMathLab they just want you to write it with a comma. So this is from negative infinity to 0, comma, 6 to positive infinity. So that's how you will write when you have two different intervals. Okay? And then the third question says, determine the x-coordinate of any inflection points of the graph. So in MyMathLab, remember before I said, okay, so now we need to know where exactly on our graph is the point of inflection. So we have to find the y value. In MyMathLab, you only have to find the x value. That's all you have to know. So the x value, where the inflection points are, is at 0 and 6. Those are the inflection points. I have an inflection point because it goes from negative to positive at 0. I have an inflection point at 6 because it goes from positive to negative. So all you have to do is write 0, 6. And again, it says, it tells you to use a comma to separate the answers. All right, so that is one of the examples of one of the questions. That's only second derivative. Now we're going to do one with first and second derivative.